Hello everybody. In the previous video we learned about graphing the quadratic function as well as expressing a given equation, a given quadratic function as in the standard form, and using the standard form how to identify the vertex of the graph. So we learned all that, and how does the quadratic function look like. It basically looks like a parabola. We learned all that, and so in this video we will learn about maximum and minimum values of quadratic function. So to define, let f be a quadratic function with standard form f of x is equal to a times x minus h the whole square plus k. So the maximum and minimum value of f occurs at x is equal to h. So the max and min values of f occurs at h. If a is greater than 0, or I already discussed about this, so that is when will the graph be upward and when will the graph be downward. So the graph will be upward if a is greater than 0, right? So if a is greater than 0, then if the graph is upward, you will have a minimum value, you will not have a maximum value. So then the minimum value of f is f of h, which is equal to, so f of h, which is equal to k. So, and if a is less than 0, as discussed in the previous video, when a is less than 0, you will have the graph to be upward. So when it is upward, it will attain a maximum value. So then the maximum value, that is max value, I will write it as max value of f is f of h is equal to k. So this is how you identify max or min values. So graphically, if you want to look at the graphs, you will have two graphs. One will be upward graph and the other one will be the downward graph. Okay, so this is a downward parabola and this is an upward parabola. So in that case, this particular point here, so the one that I'm marking in green, is nothing but h comma k. So input is h and output is k. So this is the minimum value. And when will it give you the minimum value? When a is greater than 0. So this is actually the function f of x is equal to a times x minus h the whole square plus k. And the maximum value here when the graph is upward, so this is again h and this is again k, and therefore here in this case the graph is attaining maximum value and a is less than 0 in the same equation, that is in the standard form f of x is equal to a times x minus h the whole square plus k. So using this, whatever we learned till now, we can establish the maximum and minimum values just by seeing the graph or seeing the equation and expressing it as a standard form. So we will do some problems based on this. Problem number 28. So it says that a quadratic equation of f is given. So the quadratic equation is f of x is equal to 5x square plus 30x plus 4. Okay, express f in the standard form. So to express f in the standard form, I should simplify these two terms and express it as a perfect square of the form a times x minus h the whole square. So to do that, f of x is equal to 5 of x square plus 6x plus 4, correct? So to get the middle term can be split as 2 times 3 times x plus 4. So you have to add and subtract 9 for the middle term. So we will get x square plus 6x plus 9. Okay, so plus 9 and minus 9 plus 4. So this minus 9 should be multiplied by 5 to take it outside the brackets. So then we will be getting it as 5 times x square plus 6x plus 9 into minus 45 plus 4. Okay, so the term, if you simplify this and express it as a plus b whole square formula, so that would be x plus 3 the whole square minus 45 plus 4 would be minus 41. Okay, so if you compare the given equation with the standard form, that is a times x minus h the whole square plus k. So our a value is 5 and h value is negative 3 and k value is negative 41. Okay, what else we are asked to find? Yeah, we found out the standard form. Then sketch the graph of f. That you can do it using table of values and calculate the values of the function. Choose arbitrary x values and calculate the values of the function. So you can do it because you know already I have done many such functions. I've plotted many such functions using table of values. So please do that by yourself. And the last one is find the maximum or minimum value of f. So we do not know it is maximum or minimum value when we get this function. So but once we expressed it as a standard form here, we know that a is greater than 0. So when a is greater than 0, we have a minimum value because the parabola will be upwards. So therefore f of x has a minimum value. So that minimum value is f of h which is equal to k. So let us try that. Let us verify whether we get this, that is f of negative 3 should be equal to negative 41. So we shall verify whether LHS will be equal to RHS. So f of negative 3, to calculate that, so substitute negative 3 in wherever you have x. So our equation was 5x square plus 30x plus 4. So 5 times x square, that is negative 3 square is 9. Okay, plus 30 times negative 3 plus 4. So this will be equal to 5 nines it is 45 minus 90 plus 4. Okay, so 5 plus 4 is 45 plus 4 is 49 minus 90 is nothing but negative 41. So we are right. So what is the minimum value? Minimum value is equal to f of negative 3, that is equal to k. So that is equal to negative 41. So we can I will check whether this is true in the graph as well. So let me go to the graphing calculator here and check whether we are getting the minimum values. So by plotting the graph, y is equal to 5x square. You cannot do this, like you cannot use the graphing calculator every time unless you are asked to use the graphing calculator. Do not use it. You will have to plot it using the table of values only. So I am repeating this again and again. So if you do that, like if you use graphing calculator when you are not asked to use it, so you'll be losing points in the exam. Okay, 5x square plus 30x plus 4. Okay, this is a parabola, as you can see. So I'll just minimize this, and the extremum is, yeah, exactly, it is negative 3 comma negative 41. So whatever we did till now is correct. So I'll do the, we find out we did something which for the equation which has a minimum value. Let's do something that is opposite, that is problem number 30. Okay, so this problem says that f of x is equal to 1 minus 6x minus x square. Okay, so rewriting the function as negative x square minus 6x plus 1. Okay, I'm just reordering the terms. So now I have to simplify the first two terms to get a perfect square to express it as a standard form. Okay, for that I think it is one and the same even here, like negative x square. Okay, I will take out negative 1 common in the first two terms. So negative 1 times x square plus 6x plus 1. So this will be negative 1 times x square plus 6x. I have to add and subtract 9. So 9 plus 1. So be careful to multiply the coefficient with the negative term that you are subtracting to make it as a perfect square, to take it outside the brackets so that you get a constant last term. So some people just take this negative 9 outside the brackets as it is without multiplying it with a. So that would give you a wrong solution. So do not do that. Okay, be careful, be conscious, and while solving these kinds of problems. So this can be written as negative 1 x square plus 6x plus 9 plus 9 plus 1. Okay, so this will be negative 1 times x square, x plus 3 the whole square plus 10. Correct? So this is actually the standard form of the equation. So if you compare with the standard form, f of x is equal to a times x minus h the whole square plus k. So you have a to be equal to negative 1 and b to be equal to, not b, h to be equal to negative 3, correct, and k to be equal to 10. But a here is less than 0, that is because a is negative 1, so the graph will have a maximum value. So a is less than 0, that implies f of x has a max value. So what is that max value? It is f of h, which is equal to k, that is f of negative 3, which is equal to 10. So we can verify this again. So f of negative 3 is nothing but, substitute negative 3 wherever there is x in the f of x equation. So we get 1 minus 6 times negative 3 minus negative 3 the whole square is 9. So this would be 1 plus 9. Okay, so did I go wrong somewhere? Yeah, I'm sorry. Yeah, 6 times 3 is 18, so 1 plus 18 minus 9. Okay, so it would be 19 minus 9, that is 10. So we are absolutely right. So our maximum value of the function is f of negative 3, that is nothing but 10. So we can verify this using the graph again. Going back to the graphing calculator, plot the graph. Y is equal to 1 minus 6x minus x square. Okay, so I got the thing. Yeah, here we have our extremum, so it is negative 3 comma 10. So we are absolutely right. Whatever we did manually, we are right. Okay, there is another method of finding out maximum and minimum value of a quadratic equation. So we will learn that now. So the quadratic equation is given to be the max or min value of a quadratic equation f of x is equal to ax square plus bx plus c occurs at x is equal to minus b by 2a. Okay, this is something that you can use the original given equation. You need not to express the equation in the standard form. So you just can use the original given equation and establish the maximum point. And if a is greater than 0, then the min value, that is the minimum value, is at, so actually the minimum functional value is at f of minus b by 2a. So this particular point will give you the input value where the function attains its maximum. And next, if a is greater than 0, then max value will be is at f of, again, so the same two conditions apply. So these two conditions will give you the maximum and minimum functional values, but this condition will give you the input value at which the function attains its maximum or minimum values. So we shall do some problems based on this. Okay, so let me do problem number 38 for you. So problem number 38 states that f of x is equal to 6x square minus 24x minus 100. Okay, so this a is 6 here and b is negative 24 and c is 100, sorry, negative 100. So now we are asked to find the maximum or minimum value of the function. So I will use the use this formula to find out maximum and minimum value of the function. Okay, so that would be a is greater than 0. So once a is greater than 0, we have a maximum value. Therefore f attains a maximum value. So that maximum value is nothing but f of minus b by 2a. Correct? So that is f of, what is minus b? That is minus of minus 24 is 24 divided by 2a. So 2 times 6 is 12. So this is nothing but 2. So this is f of 2. Okay, so what is f of 2? If we calculate it, f of x is nothing but 6x square, that will be 6 times 4 because 2 square is 4, minus 24 times 2 minus 100. Correct? So this would be 24 minus 48 minus 100. So you get 24 minus 148. So that would be negative 124. So this is the maximum value of f. So you can verify that through the graph as well. I would like to do another problem, which is actually a word problem. This is number 55 in the book. So this is about advertising. The effectiveness of a television commercial depends on how many times a viewer watches it. So after some experiments, an advertising agency found that if the effectiveness is E, so this is nothing but effectiveness of an ad. Okay, an ad is not our mathematical ad, it is advertisement. Okay, I should not have double D. Okay, that confuses. Okay, single D, fine. So that E represents effectiveness of an ad. After some experiments, an advertising agency found that if the effectiveness E is measured on a scale of 0 to 10, it is measured on a scale of 0 to 10, then it can be represented as a function like E of n is equal to 2 over 3 times n minus 1 over 90 n square, where n is the number of times a viewer watches watches the ad. Okay, so we have to, for a commercial to have maximum effectiveness, how many times should a viewer watch it? So I have to calculate E of, when does E of n attains its maximum value. So that means I have to calculate the input n. Okay, so I have to calculate what is our n and when does E of n attain its maximum value. So we understood, I just explained to you, like x value, the input value at which the function attains maximum or minimum value would be negative b over 2a. Correct. So doing that, we get, first we will extract all the data from the given equation. That would be a in the given equation is negative 1 over 90, b in the given equation is 2 over 3, and c is 0. Correct. This is the equation that we are considering. Okay, so now we are calculating the input value. So n will be equal to negative b over 2a. So what is negative b? It is minus 2 over 3 divided by 2 times negative 1 over 90. Correct? So this is equal to negative 2 over 3 times negative 90 divided by 2. So this is 2 and 2 will get cancelled. You have 3 ones and this will be 330. So negative and negative sign when multiplied will give you a positive sign, and you will have so you will have 30. Okay, you'll have 30 in the output. So this would be 30 times. For the ad to be effective, for a commercial to have maximum effectiveness, a viewer has to watch it 30 times. Okay, so this is where we found out the input value for which the function is maximum. Till now we have been doing the functional value, that is the maximum or minimum functional value. I know that there has been some problems assigned like from 59 and 61, some odd problems that are application related to maxima and minima. I'll be teaching that when I teach you the modeling of functions, that is the previous unit. It is a kind of a unit which is not included as a chapter or a section. Which is some kind of green in color. So you just have to learn that first before learning the application method of maximum and minima, like before solving the application problems of maxima and minima, especially the ones with 59 and 61. Okay, so I will be giving out quiz questions in this video. So quiz 3.1.1 will be number 18, number 24, okay, number 34, number 38. I do not know, I did 38. Okay, so I'll give you 44. Okay, and number 62. So 62 you can do it only after I upload the modeling of functions video. So applying and modeling functions video, with that I will teach you using an alternative method, using the whatever we learned in this video, that is section 3.1. We can use alternative methods to find out maximum and minimum values. We will learn in parallel both the methods. Okay, so we'll see you soon with that video. This completes quiz 3 questions and all the videos. Hope you are finding it helpful watching the videos. Do let me know if you have any questions in the office hours tomorrow. Thank you.